Hello everybody and welcome back. Root Beer here with question 16 on the 2007 Gauss paper, the grade 8 Gauss, not the grade 7 Gauss. So let's have a look here. So question 16, when the radius of a circle is tripled, so we multiply it by 3. How are the area and circumference of the circle affected? Okay, there's a general answer for this and I'll get into it in a moment. But, we're not talking about a particular circle that they've given us. We're being told the radius is tripled. So how about we pick a circle and see what happens? How about a nice circle like, the unit circle? So the unit circle is one that has a radius of 1. So how do we get the circumference of a circle if we know its radius? Well, it's 2 pi times the radius. So in this particular case, it'll be 2 pi times 1, or 2 pi. How do we get the area of the circle? Well, it's pi r squared. In this particular case, it'll be pi 1 squared, or pi. Okay, so that's our starting circle. And then we go ahead and we triple the radius. Okay, so if we triple 1, we get 3. So now our circumference is 2 pi times the radius, which is now 3. That's 6 pi. How did 2 pi and 6 pi relate? Well, it's tripled. And now the area is pi r squared, but the radius is now 3. So it's pi 3 squared. That's 9 pi. How does how do the two areas relate? Well, one of them is 9 times the other. Okay. So if we go back, we read our possible answers. So we have things like the area is 9 times as large, the area is 3 times as large, the area is 6 times as large. We know the answer is the area is 9 times as large. Only one of these has that. So automatically the answer is A. But we can double check. They also say the circumference is 3 times as large. Yeah, that's true. That's what we found out. Okay. Now, in general, I don't do this with one. I could do this with a general circle. The circumference is going to be 2 pi r, and the area is going to be pi r squared. And if I triple my general circle, the radius becomes 3r. So my circumference becomes 2 pi 3r, which is 6 pi r, which is 3 times the original circumference. And my area is going to be pi 3r squared, which will end up being 9 pi r squared, which is 9 times the original area. Okay? Even better than that, if you take any old figure and you blow it up in a certain way, suppose this figure is determined by this side length's distance from the center, and we call this, h. If we blow it up by a certain amount, just based on this age, you increase the one. If you increase all lengths that define your figure by a certain amount, let's actually we've been using r in the question, so let's call it k. If everything gets stretched by k, all lengths will multiply by k. All areas will multiply by k squared. And all volumes will multiply by k cubed. And this is true not just for circles. Try it with equilateral triangles. Try it with squares. If I have a square and I double its side length, the perimeter is going to double because the perimeter is a length. But the area is going to quadruple because 2 squared is 4, and areas increase by our factors squared. And so if I had a side length 1 here, I'd have a side length 2 here. K is 2. The area is going to be 4 times what originally was. Okay? So that's a nice little extra add-on. I mean, we've already answered the question quite a long time ago. The answer was A. But I just thought I'd bring your attention to, yes, you can do a specific case with a specific circle. We can do some general circles. Or we can realize this is a nice property of all figures. Okay? If you blow up figures in a certain way, the length, all lengths will be affected in a predictable way. So when I say all lengths, I'm talking perimeters. I'm talking circumferences of circles. I'm talking altitudes of triangles. I'm talking side lengths. All lengths are stretched by that same amount. All areas are stretched by that amount squared. All volumes by that amount cubed, and if you want to do four-dimensional stuff, you can reasonably expect it would be stretched by that same amount raised to the power of 4. Okay? So it's a nice little result. I know probably overloading you with information, but I just want to get that out there so you see it at some point. Okay? So that was what? Question number 16. I will see you guys for Math Idol, apparently, in question number 17. Until then, have a wonderful day.